Hello everyone, my name is Brooklyn Myers and I am an Elixir newbie. My goal is to help people adopt Elixir and grow as developers while doing the same myself. I do that by documenting and sharing my own experience in the Elixir industry. It's been an incredible journey so far and I look forward to taking the next step with you. So let's jump in to the Elixir Newbie Podcast. Today I'm talking about something that is integral to understanding programming, but is also going to be an interesting challenge for me and possibly for you, because I'm talking about something that is very technical, that involves written instruction to some degree. And so talking about it on a podcast, I think is going to be really interesting because I'm going to have to use the nomenclature of describing data. That's what we're talking about today, is data. And I'm going to have to do that in a way that is understandable in an audio form. And at first, when considering this topic, thought maybe this isn't the right thing to talk about in a podcast. Maybe this isn't a topic that is suited for this. Maybe I should just make a video or put out a blog. But in thinking about that, I realized that most of the conversation around programming in person occurs without a screen, without code examples, and without the information in front of you. And so there's this skill to practice, which is the ability to understand when someone is talking about something that's very technical. And I was talking to a fellow newbie the other day, and we were talking about listening to some of the other podcasts out there. And the people on a lot of the podcasts in the Elixir space, in fact, every one that I've heard, are brilliant developers, and they really know their stuff, and they really know what they're doing. And so they're able to have these very high-level conversations around complicated topics. But as a newer developer, it's very easy to get lost in that conversation because terms are being thrown around. It takes you a second to understand what's being talked about. Maybe you're not familiar with a particular concept, or it just takes a second to kind of pull it back up to your memory and go, oh, right, that's what a gen server is. And so it becomes very difficult to follow. In fact, I do these Twitter summaries about podcasts and other topics, but often podcasts. And one of the reasons that I do that is because I was having that experience of listening to other podcasts and walking away from it going, what do I actually remember about what was talked about? And realizing it was almost nothing. I wasn't really absorbing it because I wasn't able to follow the discussion at a high level. And so those Twitter summaries are a way for me to practice the act of listening to a complicated technical discussion and absorbing the information as best as I can. And so I think this topic is a good opportunity to practice that, but about a simpler subject than some of the higher level concepts that are being talked about out there. So today I'm talking about data. So what is data? In programming, data is everything. Data is information. When you go to your Facebook page, or sorry, I'm dating myself. When you go to your TikTok page, let's say, I've never been on TikTok, so I don't even know if you have pages, but when you go to your social media profile and you see all of that information about you, it says your name and maybe your age and where you're from. All of that is information that is somehow stored as data by the company who makes that social media application. That data is persisted somewhere, which means that it's kept in a long-term storage. And when you open up your phone or open up your browser on your computer and you go to that page so that you can see your information, that information is then requested and displayed on your machine. And so understanding how do you take information in the world and then model that in a program is incredibly fundamentally important so that you can build programs that work and build programs that work in the real world and represent everything around you. And so now the challenge of that is that computers don't understand information the way that we do. Computers represent information as binary, which is essentially zeros and ones. And so as programmers, we needed to figure out, how do we communicate effectively with a computer without needing to reason in binary, because it's very hard to think in binary. And so we create these data types that are higher level representations of binary that allow us to reason at a higher level. And it's important to understand that all data essentially boils down to binary under the hood, but you don't need to think about the binary that's happening because there's this abstraction. So in this case, just jumping into examples, 3 common data types represented in pretty much every programming language are integers, strings, and floats. And so integers are just numbers. They are round numbers. So as soon as it has a decimal place, so like 2.5, that is a float. But something like 2, 3, 4, that is an integer, and they can be negative and it's still an integer. So like -5, -4 is an integer, and so is, well, 5 and 4. Same thing with floats. You can have 5.6, but it's also still a float if it's -7.2. And so you can still, it's not about positive or negative, it's just about, is it a rounded number or is it a decimal? And so it's important to understand that all data for the computer is represented in binary. So binary is just zeros and ones. And we use that binary to compose into higher level types that, as the programmer, are easier to reason about. You wouldn't want to build your program in binary because that would be incredibly difficult to understand and read. So we've created these programming languages that allow us to reason about how to give the computer instructions at a higher level without needing to worry about the low-level implementation of those details. But essentially, all of that is a facade for the actual binary representation of the program that you're building. And so it's important to understand that that's what's happening. It's not necessarily important to understand binary. I wouldn't say that as a new programmer it's particularly important to understand that, but it is important to understand that data composes into more complex data, and that what you are using is just a representation of what the actual instruction to the computer is. And so for you, you might use simple data types like strings, floats, and integers. And pretty much every programming language has some sort of representation of these data types. A string is for representing text. It's often single quotes or double quotes, and then whatever text information you want to put inside. So it could be a paragraph, it could be your name, it could be any sort of symbols that you want to represent as text. Integers are just numbers. They are round numbers, so things like 1, 2, 3, 4, 5, they can be negative, -2, etc. As soon as they become decimals, though, so if you're doing something like 2.5, that's then a float, and that's represented differently to the program. But under the hood, all of those boil down into binary. And so binary is bits and bytes. So a bit is a 0 or a 1. At the computer level, that's just representing an electrical signal. So you can think of it like an on-off switch. And so all of programming is just very, very clever ways of arranging and organizing on-off switches. And so in this case, using those bits and putting them in a byte, which is a series of 8 bits, so just 8 zeros and ones in a row together, we've created this base 2 counting system, which allows us to represent numbers and strings and all sorts of stuff. And so what's a base 2 counting system? Well, you're likely familiar with our base 10 counting system. So we have a system where you count from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you shift the placeholder over to the left and you start counting at 1 again. And then you go 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And that's when you essentially reset back to 0 and shift the number in the second place. And so that's a base 10 counting system. So every time you hit the number 10, you shift the number over and increment the next placeholder. So a base 2 system is the exact same thing, except the moment you're about to hit the number 2, you then shift the placeholder over. So you would count as 0, 1, and then shift the placeholder over. So you now have 1, 0 together. And then you would go 1, 1, and then as soon as you're about to go to 2, you shift it over, which then in the second placeholder would turn that into a 2, and then you shift it over. And so you don't need to really understand binary. I just want to give you a small example of how binary works. But essentially each placeholder, and there are 8 placeholders because there are 8 bits in that byte, represents a power of 2. So you can count going from representing 0 to 2 to 4 to 8 to 16 to 32 to 64 and then to 128, which means that the maximum number you can store in a byte is 255. If every single placeholder were a 1, the maximum number would be 255. And so you see now we've converted those, we've used that byte to represent an integer. And then strings are doing the exact same thing. There's just an agreed upon code of what byte sequence represents what character or symbol. So for example, the letter A represented as a byte is equivalent to the number 65. And there's just this alphanumeric code that represents a letter. And so if you forget this in 10 minutes, that is totally fine. This is not, I think, fundamental to understanding programming. I just want to give you an understanding of how these things compose into each other. So we've now covered the very basic data types of strings, integers, and floats, and hopefully you understand how those are, or that those are boiled down into binary at the computer level. Beyond strings, integers, and floats, we also have a data type specific to Elixir, which is an atom. And an atom is a constant whose name is its value. So to represent an atom, or to create an atom, you use a colon, and then you give it a name. And so that name represents its actual value under the hood. And this can be used in a lot of cases where you want to for example, if you're sending a message and you want to know what type of message it is, it's often used to match on so that you can use this constant throughout your application. Now, an interesting thing about atoms is that they are essentially stored globally in your program. And so one thing to be careful with as you're considering security in your application with atoms is what I think is usually referred to as atom overload. So essentially, if you are converting arbitrary strings, so that's strings passed in by a user that they can control what they are, and converting them into atoms, it provides this opportunity where the user could send you an incredibly long list of strings that are going to be converted into atoms. Those are then stored globally, and that can actually crash your program because there's too many atoms available. So that's just one thing to know about atoms that I didn't know, and I got some feedback on in a PR, so I thought I would share that little tidbit about how they work. And last but not least, most people might start with this because Booleans, which is what I'm about to talk about, they are very, very close to the binary representation. In fact, they essentially represent bits in the way that a bit is an on-off, it's a 0 or 1, and a Boolean is an on-off, it's true or false. And the reason I talk about Booleans after atoms is that in Elixir, Booleans are actually implemented as atoms. So when you type true in your Elixir program, it's essentially just an alias to :true and :false. And so they just represent, or rather internally, they are represented by atoms under the hood. The names of modules are also represented by atoms. So when you have your Elixir app and you have your module, that internally is actually an atom. And if you call the isAtom function on a module name in your Elixir application, it will actually return true. And atoms can also be used to refer to Erlang libraries. So, for example, there's an Erlang library called ETS, which is an in-memory table in Elixir. And you can refer to that by using the :ETS syntax to refer to the ETS atom, and then access all of the different functions that are inside of it. So that's one other way that atoms are leveraged in Elixir, is to represent internal Erlang libraries and make it clear that you're using an Erlang library as opposed to a module from either an Elixir library or an internal module. Okay, so now you understand all of the low-level types that are used in Elixir. And so now we can move into some of the higher-level types. So the first higher-level type I'm going to talk about is lists. And so lists you can think of like, well, a list, a to-do list, a shopping list. They are collections of values that are separated by commas and put into a list using the square bracket syntax, and they can contain essentially any type of value inside of them. And one implementation detail that's important to understand about lists is that in Elixir, they are implemented as what's called a linked list. So essentially, the first element in the list points to the next element in the list, which points to the next element in the list, which means that you can't just immediately go to the third element in the list in the program. The computer needs to traverse through the entire series in order to find a particular element in an index. And so it's important to understand that if you have a very long list or large list, then accessing the length of it is something that is going to run in linear time. It's a potentially slow operation if you have a very, very long list. And because of that, because you have access to the first element but not the lower level elements immediately, it's often faster to prepend in a list, which means add the new element to the start of the list, than it is to add an element at the end of the list. And now, where lists are, because they are linked, are very slow to access lower level elements in the list, there's another data type used to solve that problem, which is called a tuple. So tuples are very much like lists, except instead of linking each element together, they are stored together in memory. And so that means that you know where you can access any elements in that tuple, but if you want to change that value, it's very expensive, because the benefit of a linked list is that you just need to store the element and a pointer to the next element. And so you can store that next element anywhere in memory. But with a tuple, you need to store the entire tuple in a single location in memory, or rather in a continuous location in memory. And so if you want to change any of those internal values, you need to now re-update the entire structure and figure out where it's all going to be stored. So that can be very, very expensive. So it's important to understand what each of those data types are good at so that you can use the correct one for your use case. Now, there's a special type of list called a keyword list, which is essentially that similar list of elements, except the elements are key value pairs. And it's a key value pair using an atom. So whenever you have a key that is an atom, you'll type the name of the key and then the colon at the end as opposed to the start, and then you'll give it the value. So if you're familiar with something like JavaScript objects, it looks a lot like an object syntax, except with square brackets because it is a list. And so that allows you to create this list, but have these key value pairs inside of the list. And internally, those key value pairs are actually represented as tuples. So it's basically a syntax sugar, a piece of syntax sugar for having a list where every element is a tuple that has two elements inside of it representing an atom for the key, and then the value can be whatever you want it to be. And it's important to understand keyword lists because one of the most common applications of keyword lists is passing in an arbitrary number of arguments to a function. So if you have a function and it takes in, let's say we have a function called print person, and the first argument of that function is the name of the person, and then you want to have a series of pieces of information about that person. So that would be passed in as an arbitrary number of arguments, each of which is going to have a key representing what information it is, and then a value representing the value of that information. So in this print person function, you could pass in a key value list where one of the elements has a key of birthday and the value is the year that they were born. And then it might have a key that is age and then the current age that they are. And you could use that to take an arbitrary number of arguments into the function and then use them however you're going to use them in that function, in this case printing all of the information about that person. And you'll often see this passed in as ops in functions. So if you ever see opts, as in OPTS, it's just shorthand for options. That is often being passed in as a key value list so that you can just pass in as many parameters as you, or as many arguments as you want. It's also important to note that keyword lists are ordered, so the order that you pass elements in does matter. You can also have duplicate keys. So that can be used in really interesting circumstances. For example, maybe you have a list with all sorts of different keys, and those keys represent a particular way that you want to modify some information. And you can then call that in a function and pattern match as you iterate over those keys and handle each key differently in your function. So that can be used in some pretty interesting ways. So as just kind of a bit of a I don't think you would ever use this, but it does demonstrate the point. You could have a list where you have a series of keys for where the key is add or multiply or subtract, and then each one of those values you then enumerate over, and you collect the total and call either multiplication or addition or subtraction based off of the key that's in the list, because you're pattern matching on that key, which allows you to handle different elements differently. And then you take the current total of the mathematical operation and call either addition, multiplication, or subtraction, depending on what the key is. So that's just an example of how you could use that in a kind of neat way. And the final simple data type I'm going to talk about in this episode is a map. And so a map in Elixir is the go-to key value structure. So if you're coming from a JavaScript background, you can think of maps as kind of like objects where you have key value pairs. But what makes them different from a key value, a keyword list rather, is that, one, the keys are not ordered, so the order of the keys doesn't matter. Two, you cannot have duplicate keys, so you have to have a single value for a single key, so that is enforced. And three, it also allows you to define different types of keys. So in a keyword list, the keys are atoms, and that's essentially it. But in a map, you can have a string key syntax, which is that you define your key as a string. You can use an atom syntax, which comes with some interesting syntax sugar, so it looks a little bit cleaner to have your map with atoms. Depending on the project, this is sometimes used to convey meaning. So I've seen projects where any external information that is not safe or not necessarily trusted is represented using string keys, and then any internal data that has been validated and is trusted is represented using atom keys. And the cool thing about maps that I've been playing around with recently is that maps can actually have essentially any value as the key. So you can use a tuple to represent the key. You can use pretty much anything as far as I'm aware. There might be some restrictions on it, but because of that, you can do some pretty cool stuff with it. So I was recently working on an open source project. I was working on elixirschool.com, and they have recently migrated to a new version of the website, and it's looks really clean. I definitely recommend you check it out. But in doing that, some of the URLs changed for certain resources. So they do a bunch of different lessons on Elixir, and those lessons had been moved around and put into different categories, and that overall was a benefit. But now you have old links in the system, or for example, someone may have bookmarked a specific page or referenced it in a blog post or something, and now that URL is dead. And so I was working on remapping old URLs to new URLs and making sure that we redirect from an old URL to the new location that it's stored, so that people with those outdated links don't get 404 responses. And in doing that, I wanted to quickly represent the URLs without having to type out the whole thing. And the convenient thing about these URLs is that they're all section and then name. So you have a section for the lesson, and then you have the name of the lesson, and the sections and names may have changed, but the overall URL format remained the same. And so I represented this as a map, where the key of the map was a tuple with the old section and name, and then the value of the map was a tuple with the new section and the name. And so that made it easy when I wanted to pattern match, when I was enumerating over the map to make sure, hey, when I check, when a user goes to the old URL, they should be redirected to the new URL. That made it easy to extract out those values as I was enumerating over the map and form the URLs that I needed. So that was an interesting use of maps that I really hadn't done before, and shows some of the power of being able to use different types of keys for a map. So that's one interesting thing to know about maps and how they're represented. So that's going to be it for this episode of the Elixir Newbie Podcast. There are some other data types to cover, such as structs, but this should give you a solid foundation in order to understand data and work with the data types that exist in Elixir. If you'd like to go further and learn about some of the other data types there are in Elixir, or more about Elixir in general, there's a great website that I already talked about called elixirschools.com, and you can go to that website. They have a new updated visuals for the website. It is even easier to find what you're looking for. And as always, you can chat with me on Twitter. I'm at Brooklyn J. Myers, and I hope you have an excellent rest of your week.